today's session. So very good morning to my dear students. I welcome you all into the industrial pharmacy first. Okay, so there are some of the system issues. Okay, so we had already started the parenteral products, isn't it? So in our previous lecture, we had gone through the definition of the parenteral product, the basic concept associated with the parenteral dosage form. We saw the different advantages, different disadvantages for the parenterals, the ideal properties for the parenteral product, and the pre-formulation factor in the sufficient detail with respect to that of the parenteral dosage form. We had also gone through the different routes of administration for the parenteral dosage forms. Now, today we have to see the important steps that are involved in the parenteral production. So here we have to see the components of the parenteral formulation, the methods of preparation and properties of the water for injection, and some of the importance of tonicity and the method of its determination. So in order to study all these, our lesson plan that will move through the formulation of the parenteral, in which we have to see the basic steps of parenteral formulation, then the production of water for injection, how it will occur through the use of multiple multi-effect still, vapor compression, and the reverse osmosis process. Then we have to see the formulation components, like say the different kinds of vehicles that are used, the vehicles that may be aqueous vehicle, non-aqueous vehicle, and other added excipients. Then we will see some of the methods that are used in order to adjust the tonicity, in which we have to see the class 1, class 2 method. Class 1 method that will consist of freezing point depression and sodium chloride equivalent method, whereas the class 2 is concerned, it is the White Vincent method and the Sproul's method. Sproul's method, that is also called as the modified White Vincent method. So let's go through the different kinds of vehicles that are used in case of the parenteral preparations. Now, in order to be safe, effective, and stable dosage form as a parenteral, it must be free from that of the microorganisms. That means it should be sterile, complete absence of the microorganisms and their contamination. It should be free from that of the pyrogens. Pyrogens, these are the endotoxins. It should be free from that of the particulate matter, and it should be isotonic with that of the blood plasma. Now the different steps that are involved for the production of parenteral, as you can see, first we require the cleaning of equipments, cleaning of all the glasswares. Then the preparation of the bulk product, like say the solution. Then the filtration that is in order to remove any kind of particulate matter. Then filling of solution or filling of product into the ampoules or vials, followed by sealing, then the sterilization, that is said to be the terminal sterilization, and to perform the test of quality control. These tests need to be performed onto the parenteral product in order to ensure their qualities. Now, which are the different types of vehicles that are used for the parenterals. So basically, we are using the aqueous and non-aqueous vehicles. So here we are using the aqueous vehicle as the sterile water for injection and the water for injection. As far as the non-aqueous vehicle is concerned, it is the fixed oil, and these fixed oils are going to be used as a vehicle in case of most of the products, most of the substances like say the vitamins. As far as the United States pharmacopoeia is concerned, the water for injection, it is intended to be used as a solvent. It is used as a solvent for the preparation of the parenteral solutions subject to final sterilization. There should be a use of suitable means in order to minimize the microbial growth, or first render it sterile and protect it from the microbial contamination. Sterile water for injection. The sterile water for injection is water for injection sterilized and suitably packed. It contains no antimicrobial agent or any other added substances, and it is used as a solvent for parenteral products such as sterile solids that must be distributed dry because of limited stability of their solutions. It must be packed only in single dose containers of not larger than 1 liter size. So that is what is the sterile water for injection. You can see what is the difference between the water for injection and the sterile water for injection. The water for injection that is intended to be used as a solvent for the preparation of the parenteral solutions, and it is subjected to the final sterilization. See, after preparation, the product that will be sterilized and the water that will get sterilized along with the product in case of the water for injection. But in case of sterile water for injection, it is the pre-sterilized one and it is packed, and it will not contain any kind of the antimicrobial agent. It is used in order to reconstitute the solution. The non-aqueous vehicles, they should qualify the limit as per the USP for free fatty acid content, iodine value, and the saponification values. The method of preparation of water is concerned, the distillation or by membrane technology, like say the reverse osmosis or ultrafiltration. These are the membrane technology methods which are used in order to produce the water for injection. As far as the European pharmacopoeia is concerned, the distillation is the method which is used in order to produce the water for injection. And as far as the United States of pharmacopoeia, Japanese pharmacopoeia is concerned, the distillation along with the reverse osmosis and ultrafiltration, these are the technologies that are used in order to produce the water for injection. Some of the water miscible vehicles that are generally used, which are said to be the co-solvents, like the glycols, PEG, polyethylene glycol, polypropylene glycol, or propylene glycol. Sometimes the glycerin sorbitol that is also going to be used. Now these are going to be used when the water that is not suitable. In that case, these co-solvents are going to be used. Like say for example, ethanol that is going to be used in case of the preparation of the cardiac glycoside parenteral products, and for the preparation of the barbiturates, the glycols are going to be used as a vehicle. This is the way by which the process of distillation that is to be carried out, and the whole assembly that is said to be the distillation apparatus. You can see there is a condenser, there is a round bottom flask, there is a spirit lamp, and there is a conical flask that will collect the distillate. The water that is going to be fed into this round bottom flask, it is going to be heated, and the suitable space, headspace that is to be maintained. So water that will get converted into the vapor and the non-volatile content, they will remain here only, whereas the converted vapor, they will passes through this condenser. Now in this condenser, there is a circulation of chilled water, cooled water. That is, this is the inlet for the cooling water, this is the outlet for the cooling water. And the water vapor that will get condensed because of this condenser, and it is going to be collected into this conical flask in the form of the distillate. So this is the distilled water. So water for injection that can be produced by the distillation unit, like say the vapor compression steel and the multiple effect steel. So this is the vapor compression steel. You can see there is a water that is going to be fed from one side and the distillate that is going to be collected. In the meantime, the water that will passes through this vapor compression steel, where the steam that will get condensed and it is going to be collected in the form of the distillate. Now this vapor compression steel, it has various advantages. The very first is the low energy consumption. Second is the no need of cooling water to condensate the pure steam as it is required in case of the distillation unit, distillation apparatus. In case of vapor compression, there is no need for the high quality inlet water. No need to pressurize the inlet water. Extremely safe process with no risk of any contamination through plant steam or inlet steam. This may not be there in case of the distillation apparatus. And this has a very robust equipment, and because of which it is not having any kind of mechanism, or if it is there, maintenance that will be reduced one. So here you can see there is a multiple effect steel. You can see the multiple effect steel. In case of multiple effect steel, the process how it will passes, you can see the water that will passes or that will be subjected to the different steam condensers. So in case of first one, you can see the pure stream that is going to be passed through the second, and once it is there into the second, then from second it is going to be passed into the third one, and likewise, and from third one then it is going to be passed through the condenser, right? So it is subjected to be passed from first to second to third and then through the condenser in order to collect the distillate. So as it will passes through the multiple stages, so there is a still, or the still is properly called as the multiple effect still. Another method by which we can go for producing the water for injection, that is the reverse osmosis method. You can see the picture here. The osmosis, it is particular the process in which the semi-permeable membrane that will separates and from low concentration to that of the high concentration, that is the flow. Now, reverse osmosis, what? It is a selective reverse permeation of molecules through a semi-permeable membrane separating the two aqueous solutions of different concentrations. A driving force usually between 200 to 400 psig per square inch gauge is required to overcome the osmotic pressure and to permeate the pure water to pass through the membrane. So the driving force, how much it is required? 200 to 400 psig in case of the reverse osmosis. Reverse osmosis, that will consist of the membrane, or through the RO membrane, the liquid that will be allowed to pass, that is said to be the RO membrane. And this RO membrane or the reverse osmosis membrane that is made up of cellulose acetate or the polysulfone coated with the aromatic polyamides. Now, sometimes the passage through these two membranes in series is used in order to increase the efficiency of removal of these small molecules. We need to pass it through the multiple layers or several membranes in order to achieve the efficiency of removal. It also decreases the risk of structural failure of a membrane to remove other contaminants such as bacteria and the pathogens. Sometimes both reverse osmosis and distillation systems, these are used for generation of the high quality water. So we can go for use of a single method or we can go for use of a combination method. Multiple methods we can use. Since the raw water with greater impurities can contaminate the distillation unit and affects the operation of the still, the water is first run through the reverse osmosis units in order to eliminate the contaminants. So reverse osmosis or the RO, that is most important one. Next method is the ultrafiltration. So hydrostatic pressure forces a liquid against the semi-permeable membrane. In principle, ultrafiltration is not different from reverse osmosis, except in terms of size of the molecule that it retains. So high molecular weight that is going to be retained, and high molecular weight, low molecular weight that will be passes. Now, as far as the storage conditions of the water for injection and the sterile water for injection are concerned, generally it has to be stored at a temperature of 80 degrees Celsius. But this temperature of this much high temperature of water that cannot be used for the process of preparation. So it has to be passed through the heat exchangers in order to reduce the temperature when it is required for the time of preparation. Now, the water that cannot be stored for more than 24 hours, so it need to be frequently sanitized. So frequent sanitization that is required, because if it will remain for more than 24 hours, the chances of contamination or the growth of microorganism that may occurs. The water for injection or the sterile water for injection that is stored in a stainless steel tank and the hydrophobic membrane vent filters. You can see all these are the acceptance criteria as far as the description of water is concerned. The water that should be clear, that should be colorless, that should be odorless, liquid. The total organic carbon that should not be more than 500 parts per billion. As far as the conductivity at 25 degrees Celsius temperature is concerned, it should be less than that of the 1.3 millisiemens per second. Bacterial endotoxins are concerned, their concentration that should be less than 0.25 endotoxin unit per ml. And the total aerobic microbial count is concerned, that should be less than that of 10 cubic feet unit per 100 ml. Acidity alkalinity is concerned, no red or blue color that should be there. pH is concerned, that should be between 5 to 7 for the water which is to be used for the parenteral preparations. If we see the isotonicity, the most important parameter that is there required in case of the parenteral preparations. So the parenteral product that should be isotonic with that of the blood plasma as to avoid any pain or discomfort or swelling and contraction of the blood cells. What will happen suppose if we are not maintaining the isotonicity? Already we saw in our yesterday's lecture that if we are not maintaining the isotonicity, if the solution is hypotonic, that will lead to the swelling of the RBCs and hemolysis. And if it is hypertonic, then that will lead to the process of shrinkage of the RBCs. So in order to maintain the isotonicity, we require the 0.9% of the sodium chloride that is said to be the isotonic and used as a standard in pharmaceutical preparations. In order to make the solution product isotonic, we require the adjustment of the tonicity. And in order to adjust the tonicity, we are having the different methods, like say the class 1 and the class 2 methods of adjusting the tonicity. The class 1 method that include the freezing point depression and the sodium chloride equivalent method. Class 2 that will consist of White Vincent method and the Sproul's method. Sproul's method that is also called as modified White Vincent method. Now how these methods they will work and how this is to be carried out. So you can see here there is a formula by which we can go for calculating the method of adjusting the tonicity. The formula is W percentage equal to 0.52 minus A divided by B. Now A and B, these are the freezing point depression for the adjusted substances of 1% concentration and adjusting substances, unadjusted and the adjusting substances respectively. Now 0.52 as it is the freezing point for the blood plasma and the tears, so it has to be taken. Now in this we have to put the values. So let's see an example that how much sodium chloride is required in order to render 100 ml 1% solution of apomorphine hydrochloride isotonic. So the freezing point depression of 1% sodium chloride, that is the 0.58 degrees Celsius, and freezing point depression of 1% drug, that is the apomorphine hydrochloride, is the 0.08 degrees Celsius. So just by putting all these values into the formula, W percent equal to 0.52 minus A divided by B equal to 0.52 minus 0.08. So that is the unadjusted substances and its freezing point. So that is for the apomorphine 0.08 divided by adjusting substance, that is the sodium chloride 0.52. So that will gives you the percentage of the 0.76. So 1 gram of drug and 0.76 gram of sodium chloride and make up the volume to 100 ml, that will give you the isotonic solution. In case of sodium chloride equivalent method, sodium chloride equivalent E is the amount of sodium chloride that is equivalent to, it has the same osmotic effect as 1 gram of the drug. This method first uses to calculate the E sodium chloride, then calculate the amount of sodium chloride to reach 0.9. So the step one that will consist of ENaCl value is generally given it to you, and if it is not given, it can be calculated by using ENaCl equal to 17 point L iso drug divided by molecular weight of drug, where L iso is a constant factor based on isotonic concentration of a drug molecule. The step 2 that will consist of, in order to calculate the amount of sodium chloride to reach 0.9%. So W percent equal to 0.9 minus drug percent multiplied by ENaCl. So W percent, it is the weight of sodium chloride in gram per 100 ml. Drug percent equal to weight of drug in gram per 100 ml. And ENaCl is the NaCl equivalent weight to 1 gram of drug. 0.9, it is the isotonic percentage concentration of sodium chloride solution to the blood plasma. The White Vincent method, this method involves the addition of water to the drug to make it isotonic and addition of isotonic vehicle to bring solution to final volume. So in case of white Vincent method, what we are doing, we are adding the water in order to make it isotonic. So it has the formula V is equal to W multiplied by ENaCl multiplied by 111.1, where V is the volume of water, W is the weight of drug, and 111.1 that can be obtained by dividing 100 with the help of the zero point 0.9, or 100 divided by zero point 0.9, that will give you 111.1. Sprouse method is a modified White-Vincent method in which the total volume is kept constant to 30 ml and the drug concentration is kept constant to 1%, that is zero point 0.3 gram. This is only the modification. Now, what we require in order to produce the parenteral, we require the antimicrobials, antioxidants. Antimicrobial in order to prevent the process of microbial contamination, antioxidants in order to prevent the process of oxidation. So antimicrobial and antioxidants, these can be used as the stabilizers. Now buffer, bulking agent, chelating agent, and the protectant. So these are to maintain the properties, and there are solubilizing agents, surfactants, and the tonicity adjusting agents. So antimicrobial, like say the benzalkonium chloride, benzyl alcohol, chlorbutanol, metacresol, butyl parahydroxybenzoate, methyl parahydroxybenzoate, all these are going to be used, and their usual concentrations, as you can see, for benzalkonium chloride it is 0.01%, and for the benzoates 0.015 and the 0.1 to 0.2%. Antioxidants, ascorbic acid, cysteine, monothioglycerol, sodium bisulfite, sodium metabisulfite, these are going to be used. Sodium metabisulfite, it is to be used in 0.1 to 1% concentration. The buffers, generally acetate, citrate, and the phosphate buffers are used in 1 to 2, 1 to 5, and 0.8 to 2% concentration respectively. Bulking agent, lactose, mannitol, sorbitol, glycine, these are used. Chelating agent, the salts of ADTA, like say the sodium ADTA, that is going to be used. And protectant, the sucrose, glucose, lactose, and sometimes the human serum albumin, that is need to be added. The solubilizing agents such as ethyl alcohol, glycerin, polyethylene glycol, propylene glycol, and lecithin, these are added. Surfactant, polyoxyethylene, sorbitan, and monooleate. Tonicity adjusting agent, dextrose, and the sodium chloride. These are included in case of the uh, formulation of the parenteral products. Now, in short, if we see the summary as far as today's lecture is concerned, so what we saw in today's lecture, we saw the formulation of the parenteral, the basic steps of parenteral formulation, then the production of the water for injection, how it is going to be produced with the help of use of the distillation apparatus, multi-effect still, vapor compression method, and the reverse osmosis. Formulation component, if we see, there are other added excipients, like say the buffers, like say the chelating agents, like say the stabilizers, antimicrobials, antioxidants, isn't it? Along with the vehicle, these are aqueous and the non-aqueous vehicles. Non-aqueous, fixed oil vehicles, like say the castor oils, right? Cottonseed oils, all these are used. The tonicity, that is most important, and in order to adjust this tonicity we require the different methods that is to be used. So the class 1 and class 2, these two are the methods. In case of class 1, there are two different methods, that is said to be the freezing point depression and the sodium chloride equivalent method, whereas class 2 is concerned, it is the White-Vincent method and the Sprouse method. Sprouse method, that is also known as modified White-Vincent method. So all these are the details that already we had covered in our today's lecture. So with this, thank you very much to all of you and have a good day to you all.